All right, boys. We're doing front suspension tonight. Let me show you where we're at, what's going on. I'll try and explain a little bit. Maybe give you a little bit of advice, help you if you're crazy enough to do this shit. And yeah, we'll go from there. Okay, you can see I just have my cross member in there. It's about the same width of like a Heights Mustang 2. I did it wider because I want to try and counteract some of that leverage without having to do like weird kickers and all that other crap. There's a spacer in there I'll have to knock out. So I had, where, oh man, what, here it is. Don't mind the mess. Things are crazy these days. I had this arm. This is kind of my, mock-up arm from everything else I've done. I got it all stuffed in here. Fits, just go. We're on camera, let's make it nice. There we go. So I had this up in here. And this is for like my regular builds. It's not for this truck. It's kind of my mock-up arm that gets thrown around. You can see this is where I need to be. This is where this one is. So I gotta come forward. Which works out because I know all of my measurements on this one. Like, it's already worked out. And so we're gonna rejig it. Yeah. Which I started working on. Get some stuff out of the way. Just like normal. I mean, if you watch me do this before, you've seen me do this. You watched me do this with the Falcon. We're doing it again with this. So here's my center line. That arm was too far back, so we're moving the jig mounts further back. This is, I have an extra kicking on just for occasions like this. We're just moving everything back, the amount that it needs to move back. We started this out with you seeing me machine, and I'm just gonna tell you, when you're doing these, be very careful to bevel the edges. Like if you don't have access to a lathe, that's fine. But you need to make sure all these edges are beveled if you're gonna do bushing. So if this was straight up race, I wouldn't be doing bushings. And this, I'm gonna drive it probably more than I race it. So there's gotta be a little bit of quietness and, what's the word I'm looking for? It's gotta be a little bit tame. So I'm doing bushing here on the lower. I'm not on the upper just because I need the adjustability. And so yeah, the reason I'm doing my own and not like a Mustang 2 kit is you can see here, this ball joint is a lot bigger than what's going to come in your typical Mustang 2 front end. Your typical Mustang 2 is going to come with a ball joint about like this, not a screw in. So that's the difference on the lowers. So it's a lot. I've gone to this setup. I've had issues with the Mustang 2 before when guys have taken them and like ran road course and whatnot. There's not enough travel in the Mustang 2 ball joint that comes in all the kits. So these are actually a Dodge ball joint. So this is actually the upper now, which is about the size of a lower on a Mustang 2. This is the new screw-in lower that I use. which is twice the size of the lower that comes on your typical Mustang 2, and it actually has a little bit more articulation to it, which really means that, I mean, that really doesn't make any difference, because when you're talking about road course, say you go crashing into a corner, the whole truck leans, it's gonna lean maybe 5 degrees. There's definitely enough in any ball joint to cover that situation. But I just went heavier because I've had issues with those wearing out before. So I'm gonna finish tacking this jig together. I'm gonna hurry and get these arms built. I'm not doing a plate arm like, where'd it go? There. I'm not gonna do a plate arm like that because that 5.4 is heavy, and I know it's heavy. So I'm trying to keep everything as light in the front as I can. And in anticipation for that, you can see even my cross member, like I've gone ahead and got rid of everything that I could out of it. So I'm gonna go tubular with these. I thought about putting a bend in them. I'm not gonna do that. I'm just gonna run straight tube, bam, bam. I'll show you that in a minute. Oh yeah, I don't remember if we talked about this. Make sure that you chamfer your corners if you're doing a bushing, because I mean, this is gonna cycle thousands upon thousands of times. And if you have a sharp saw cut edge anywhere on here, it is gonna take that poly bushing and it will absolutely eat straight through it. So make sure you chamfer those. That's probably one of the most important parts. Most of your Mustang 2 arms are going to be 1 to 1.25 inches. 120 wall, I've cut a few apart. They've been 195 wall. I'm upping that just because I'm heavy up front. I plan on driving this like a pissed off teenager, so I'm doing 1 5/16, 120 wall because I have it, and I will never have to worry about breaking it. So I'm gonna get this a little further along, and we'll come back in probably after I get it all tacked together and show you all what's going on. That's why you wear glasses. All right, just to show you where we're at. You watch me notch everything in. Got a decent fit here. I'm a little gappy here. Got a good fit here. Did kind of catch my jig a little bit though. Down at this end, you saw me beat the absolute hell out of this. Ooh, that's hot. I'll probably do a little more tapping, just to smooth that out just a little bit. I'll probably do a little more tapping here, just to smooth that out a little bit. The point of this jig is to get the ball joint straight up and down at ride height. That way, as we travel, which, like I said before, isn't gonna be very much, that ball joint isn't gonna be overextended one way or the other at all. I will probably do a kicker somewhere in here. I'll probably downsize that to like 1 inch because it's really not gonna matter as much. And then if I do need to drop the shock down inside the arm, I will adjust for that when we get to that point. So if you're jigging up your tubular A-arms, this is the best way to do it that I know of. Fastest anyways. Fastest and easiest. I'm gonna finish this arm up real quick. We'll just take these measurements off of this. Everything's squared off this edge, so it's nice and easy to pull off of. I'll bust my mounts loose, move them in the exact opposite, build my other arm real quick. We'll get those thrown on. If you are doing bushing, make your plates the exact size of your tube. And it just makes it easier because like you can tack them in there and you can weld this thing clear to death and you don't ever have to worry about melting this thing. Okay? There's a lot of people like they'll build a jig, bushing in there, they'll center off the bolt hole, yada yada. First couple welds, this thing's smoked and you're out of bushing. So, quick little tip. Yeah, I'll get these finished up and then I'll probably, my big computer's down with my SolidWorks, so I can't show you this thing cycle. I'm gonna throw together some sort of redneck graph. So I can show you what geometry you need to worry about when you're doing this, because redneck is what I'm best at and it's gonna work, it's gonna be easy. And I mean, this is mostly just to show you guys that like this is something you can do. Like if you have a little bit of time, a few tools kicking around, a dirty ass shop, you can do this. This is not a big deal. So I'm gonna finish that up. I'm gonna finish both of them up. I'll throw something together to show you the math that you need to worry about, because it's really not as bad as you guys think, and we'll go from there. All right, boys. Let me zoom out. No, we don't zoom out this way. Okay, got the arms done. We did drop that down, did a 1 inch in there, ball joints in. There is our new arm. Coming over here. Let me just turn this thing. God. Coming over here. I have this mocked up here. And now you can see I'm a little bit too far forward. Not a lot, a little bit. Off camera, when I was putting everything together, I found out that this bushing, there, I was gonna have an interference issue with my rack and pinion. So that needs to move back a little bit for clearance. So I'm gonna move this whole arm back. So I built the arm in anticipation for that. Let's get this. Let me get you guys situated here. We'll go over this sweet little redneck graph and I'll show you what you need to worry about and how easy this is to figure out. This is the same size as my tire. Well, not quite as wide, but same height. This is the offset in my spindle. I have a 2 inch offset from center of ball joint to center of ball joint. This arm is built, so that measurement's set. We're not changing it. If you look here, I have my bump height, my ride height, and my droop. I'm planning on 3 inches of compression and 1 inch of droop. You can see this line right here is level with my tire. So at ride height, my camber is in. You're gonna wanna be in half a degree to 1 degree. That's gonna make it drive a little nicer. It's gonna help with your tire wear. It's gonna help with your steering when you're driving around. Now, when you go into compression, we'll go clear up to bump. You can see, well, I don't know if you can really see that. Here, where's my marker? Oh man, I lost my marker. Hang on, I'll be right back. Oh, found it, never mind, here it is. Okay, so when we come into bump, you heard me say earlier that I planned on when I dive into a corner, right around 5 degrees of body roll. So, this is a bump. We'll just go ahead and draw it on in there. We'll get this back out of there. You can see I went negative on my camber here. This is going to be important. if you're set up to where you're coming positive on your compression, it's gonna mess with your steering. You'll start getting understeer, you'll start getting oversteer, you'll end up with a mess. You want to keep it like at full droop on pretty much level, which is going to keep the bottom of the tire 100% in contact with the road. At full bump, planning on 5 degrees worth of tilt with the body. This is going to put me pretty close to 5 degrees. It's also going to keep my contact patch right around 100% with the road. This is what you want to aim for. So you never want to go positive with your camber anywhere through your suspension cycle. Like if you can come down to perfect or even maybe a degree positive at full bump, and then, well, at droop, sorry, and then at bump, if you can come back negative 3 to 5 degrees, that's going to be just about right. If you set something up like this, I mean, this is just junk I had laying around. Let me show you what can happen. Let's say we move this mounting location up to here. So at ride height, you can see, I don't know if you can see on the line, but we have our camber ride height with that upper arm location. Because remember, our lower arm isn't going to change. This isn't going to change because this is where our ball joint sits on our spindle. But now watch what happens when we cycle. See how much we went positive? I mean, we're still good there, but look how far negative we go at full droop. And this is all just changing that mount from that location to that location. So let's do it again. Let's try something else. Let's go to a longer arm now. And we'll change our mounting location again. Get in there. So now we're getting a little more symmetrical. These two are parallel, which is probably going to be one of the bigger points of the entire thing. This arm is 2 inches shorter than this arm, where this one was 3 inches shorter. Now, as we travel, you can see this is our level bump line. This is our level ride height line. This is our level droop line. That tire stays 100% level. Like we don't gain or lose any of our camber just by adding 1 inch and changing that location. So you just got to play with your mount locations. A lot of this is going to be predetermined by what you're working around, unless you're building like a full tube race car. Most of the time, that's not going to be the case. Most of the time, you're going to have restrictions. There's going to be certain places you can mount everything. You're only going to have a certain amount of freedom in how you can set this up. So you just got to work within those boundaries to figure out what's going to work best for you. This would actually be a pretty nice setup too. Like it doesn't matter how much the car dives. It doesn't matter where you are in your suspension cycle. You're going to maintain 100%. And this would be more of like a full race type setup. You could set your camber wherever you want and it's going to stay there 100% of the time, which is going to make it more predictable. I can't use this mounting position. I have to be out here. Like I have to be within a 3 inch arc of that. Just build issues. So I mean, if you don't have SolidWorks or Autodesk or anything like that, throw yourself together something like this. It's pretty easy to figure it all out. Most people aren't going to have 3D modeling stuff to figure all this out beforehand. This is $3 worth of junk that probably would have got thrown away. The only other thing you're going to want to pay attention to is your caster. Your caster is going to be how far your upper ball joint is either behind or in front of your lower ball joint. So this is also going to affect the way it steers. The more caster you have, the more the tires are going to try and return to center. So like if you're going down the road with speed and you turn and you let go of the wheel, if you're positive caster, that wheel's going to try and return to center. If you're negative caster, that thing's going to dance all over the road. It's not going to try and center at all, and it's going to be a handful. Normally, your caster, 3 to 5 degrees is where I'll set them. It gives you a good feel on the road. It gives you good stability at high speed, and it still keeps you pretty responsive when you're going through corners. So that's about it, guys. I mean, when it comes to setting up like a wishbone front end, deal with what you have to. I mean, your lower is just going to be set. Like, this is going to set if your tire fits inside your fender or not. You might have a little bit of up and down that you can go here, but this will be the first arm that you set. After this arm's set, then you come in and you figure this one out. Get all figured out where you can mount your upper mounts, where this point is. This is also a fixed point on your spindle. And you can play with different lengths of arms, different mounting positions, and everything else to get it set up exactly where you need it. So, where am I? I am going to build more stuff. And I'll check back in with you guys in a little bit. I'll probably when it's done, actually, probably when the uppers and lowers are done and on and mounted, we can cycle it, show you exactly what we ended up with, where we're at. And then we'll mount some shocks and some other stuff. I don't know, I'm trying to hurry and plow through all this. You can do a lot of searching and reading. There's so much good information on the internet. Don't trust me for any of this. This is just what I've learned. And I'm not gonna be responsible for your shit driving like shit. Stuff driving not good. Quit cussing. So, I'll check back in with you guys in a minute. Okay. I know I just said that I check in with you when I was done. Not the case. So I got the upper arm done, and I made a few changes. So this is how my upper arm is going to go. This will mount to the frame. This will go inside of it, and that will give me adjustment on top. These are just threaded for set screws. So that'll give me my adjustment this way. I made some bungs real quick, set them in this. On Heim, that'll give me my adjustment this way. And that'll take care of all the adjustment on the top. Let's walk over here. I'll show you what's going on over here. Oh, where's my light? Let me grab my light. It's gonna be dark. Okay, so this is what used to be the face right there. You can see I notched this back about like 1 3/4 inches. And then I built this support tube. So this just has a couple threaded inserts that I spun out, and then a piece of DOM in the middle. Just the bolts will go straight in that, thread into that. They'll keep all that stable. It also gave me the opportunity to make this double shear. A lot of time on a Mustang 2 style, they'll have something hanging out the back with a gusset welded in there. This one's wider than what a Mustang 2 would be anyways. They're normally yay big, but when I designed this one, I added a tail to flare the back out to give it a little bit more control. So that's done. I did put 3/16 spacers in here just so I could adjust my wheelbase a little bit if I need to, just to get the tire centered. I know I told you, or I showed you, that the tire wasn't centered, but it looks centered when I rewatched the video. The tire had actually turned a little bit, so when it turned, it moved my center, and it made it look centered in the video, but it really wasn't. So now, this is all taken care of. That's sitting right about where ride height's gonna be. I've got this kind of marked off where this is gonna weld in. So this guy's gonna weld in about right there. Now at this point, you have a couple options. You can weld it in there straight and level, and as your arm cycles, your caster is gonna stay the same. So wherever you set it, it'll remain set at that degree. You could also do, you could also set it up to gain caster under compression by angling that. What that does is it makes this upper arm travel at an arc. So where this upper arm travels at an arc, out here at the end, it's going to come back as it compresses. While your lower arm, where it's level, is going to go straight up and down. So what it's going to do is under compression, it'll cause that spindle to do this. So what that's going to do is if you dive into a corner and you roll to the outside, your outside tire is going to take 75% of the weight of the vehicle in the turn. It's the most important part of your setup would be the compression side when you're diving into a corner. When it compresses, if you gain more caster, it's going to make the wheel heavier. Like you're going to have to turn into it harder because that wheel with the extra caster just wants to return to straight. So this is going to just depend on your driving style and how you like to drive. If you're racing, like if it's straight race, that can get to be a bad thing because you get fatigued. Like halfway through the race, you're just tired of holding that damn thing and like fighting through the corners. Most race setups don't use power rack though. Power steering kind of changes that. It's gonna make it heavier. It's gonna make it feel heavier in your hand. You're gonna feel the road more, but you don't have to deal with fatigue like if you're a full race build. So I haven't quite decided if I'm gonna leave this level or if I'm gonna put a couple degrees in it yet, but I figure we go over that. So I've about got this side done. I'll probably wrap this side up, get the spindle set on, cycle it, make sure everything's where I want it. I moved my mounting location. I think you can still see it right there. You see that? That's where the arm used to mount, was in that hole. So I moved it out and down a little bit. And my purpose for moving it down was, this was originally going to be a race build. So I only planned on like 2 inches of ground clearance. Like this thing was going to, ground clearance at ride height. Like it was going to hug the road. Now that I'm going to drive it more, I've jacked it up. Now I'm going to sit probably at 6 inches. It messed with my angles. It made these steeper from what I had originally planned on. That's why I moved that down. It kind of really screwed up the way I've got to do things, because originally this upper mount was going to be up in here and I was going to fight it with my headers. But now with that down and out, I've had to move this down, which sucks, and also out my upper arms. You can see I've ended up pretty short. Like, I want to say I'm like 7.5 or 8 inches. I can't remember off the top of my head, to make it travel the way I wanted. So just that's the update on that. I did get the inside cleaned out. Had a rat problem or a mouse problem or something. It sucked up all sorts of garbage out of there. But we're gonna get this all buttoned up and probably get this intake all figured out and buttoned up. If you're watching to see if this just fits, it absolutely doesn't. Where'd my gaskets go? There they are. This is the 5.4 intake gasket, and you can see the ports actually line up pretty darn nice. Let me get this kind of in there a little better. So you can see the ports aren't really that far off. So as far as that goes, like it's pretty darn good. The problem is here. That's the bolt for the Boss intake. That's a bolt for the Boss intake. That's a bolt for the Boss intake. And if you come into here, oh, come on. Those bolts are here. So there's nothing there. MMR makes a set of plates like 225 bucks, 240 bucks, something like that. They bolt onto that and adapt it to that. We might, I think I have some 1/2-inch aluminum kicking around. I think I have some 1/2-inch 6061 over there. I might just burn out some plates. We'll, I don't know, maybe we'll make those. Well, I just don't know if it's worth it over 240 bucks, so. But that's gonna be it for this one. Next time, on the next one, I'll have this all set up. Maybe we'll go over coilover mounts and we'll go into steering. There's a lot to talk about on steering, but that's something for another episode. I mean, we're kind of going over the very basics of getting this set up. We're not getting into the math. We're not getting into the theory. We're not doing a deep dive. And we'll do the same with the steering. I'll hit the highlights, show you the basic theory, the easiest way to set it up without having to have a Harvard degree or an MIT degree, and we'll go from there. So until next time, this is Carl, No Coast Fab. Like and subscribe, click the little bell if you want to see more of this project, and I'll catch you guys next time.